Okay, thanks for joining us. We're going to present a short overview here of a new feature that's coming up soon in AMP, which is called Application Network Security. And the idea is that this is a feature which allows application designers to model within their blueprints the restrictions that they want to impose in terms of access between their application components and between those components and the outside world. So you can model your security requirements like this simply and directly in blueprints using a declarative YAML notation. And then AMP will take care of applying the rules on your behalf using whatever security mechanisms are appropriate to the cloud that you're deploying on. So we're going to show a demo here of a classic three-tier application with a load balancer front end, a cluster of web servers, and some back office services, and how you apply the rules to them. Now, I'll just quickly introduce that by mentioning that there's a blog post that describes all this for you. I won't bother dwelling on the text with it right now, but I'll just show you this diagram. And the idea is that here is that three-tier app. And around these machines, we've drawn some regions of security control, of access control. So the load balancer here, the web cluster here, and some backend services here, like a database. And each of the green areas represents a group to which access restrictions are being applied. The green lines are connectors, where one group of machines has deliberately exposed access to a selected other group. So, for example, the load balancer here is on a front end, in a front end group. It's also connected to a special group public, which means that it's also allowing access from the public internet. Whereas the web cluster group on the top right does not have public access, but however it does have ingress rules which specify that it's going to allow access to machines in the front end group, but only on the port HTTP port. Now that's a name of a sensor in the application. And similarly, the database at the bottom allows access only via the DB port to the web cluster and only the web cluster. That means that the load balancer is able to connect to the web cluster because that's allowed. The web cluster is able to connect to the database, but the load balancer, if it tries to access the database directly, will get an access denied. The mechanisms by which this is implemented are not referred to in the YAML. And the idea is that AMP is free to choose an appropriate mechanism based on the cloud you're working on. So, for example, that might be security groups, or it could be networking rules, or IP tables, or whatever. And in our first upcoming release, we're implementing this with security groups, and we're actively working on implementing that or building that out to the other mechanisms. Now, that's enough theory. I will hand over now to Justin to show you what this looks like in practice. Justin.
All right, so just wait for that to load. I'm going to show you now how we take that and put it into a blueprint. And rather than simply modeling, deploying, and managing this three-tier application, we're going to first delineate the three tiers. So this is our application. We've got a load balancer at the front, and then a cluster of application servers, so Tomcat servers or whatever you're hosting your application on. And then we've decided that we want RabbitMQ, a Redis cluster, and a MySQL cluster. So the way that we've broken this down is into a load balancer security group, an application server security group, and a back office security group. So the reason for that is we want this load balancer to be the single point of entry, the only security group that has access to the public, well, that can be accessed from the public internet. and that will be what will be our entry point into the application. So then it will communicate with our application servers, which will in turn communicate with the back office. So I'll show you what that looks like for the RabbitMQ flow. So here we can see that in the public network, we only have the load balancer, and that's defined by these networks here. So we've said this load balancer is on the public network, and public's it's a special term. It's a reserved term, and that means that it has public access. And then we've also given it this load balancer network, and we use that as a reference so that other security groups can say, okay, can refer to it. So now in the private side, so not available from the internet, we have this application servers. We define that here, and now we can define the network ingress. And so we're saying, okay, allow access from this load balancer group on port 8080. And so what that means is only this load balancer group can access, and only on port 8080. And that means that we've secured that from the public. Now going a step deeper, we have the back office. So we've defined this back office group, and then its network ingress rules are only allow access from the application servers. And on this one, we actually have two ports that we want. We have the active RabbitMQ port, which is 5673, and then a management port, so 15672. And then, so that can only be accessed from the application servers, and so never even mind the load balancer servers or the public. So then, now looking at the Redis cluster, it's very similar. We're just defining, okay, again, application servers, and we want this on only the Redis port, so 6379. And these are, as Geoff said before, these are sensors, so these are pulled from that Redis cluster. And then for the MySQL, same thing again, 3306, which is the sensor MySQL port. Okay, so now what I want to show you is what this looks like in the actual blueprint. So this is the blueprint for our application, and so you can see we've got our Redis entity, database, RabbitMQ, and then our application servers, and then the load balancer, a few other things. But so I think the best one to look at is RabbitMQ here. So these are the rules that we talked about, and so we're saying this network is the back office network, and we want to allow ingress from the application servers group, and only on these two ports. And to show you that in action, Sam's gonna take over now.
Thanks, Justin. I'll just add, while your screen's showing, it's important to note that the ports that are being exposed there, AMQP ports and the RabbitMQ management ports, are things published by the RabbitMQ entity. So they're filled in at runtime, depending on what is chosen by AMP. So I'll show my screen. Justin, is that visible?
Yes.
Thank you. I've got the blueprint Justin shared deployed in both AWS and OpenStack. And we have the 5 components. We have our data entities. We have a cluster of our Tomcat servers and our HA proxy load balancer. We also have this network security visualizer entry, which presents the membership of the networks or groups in the blueprint. So for example, our load balancer is the only thing that's in public. It's also in its own load balancer network. The back office contains our data tier. The application servers group just for Tomcats. Management is a special network that allows connectivity from AMP to each of these things. This presents the things that members have access to. It's a bit difficult to read here, but if I switch to this tab, we can see that the Tomcat servers, I'll switch to the load balancer. We can see that the load balancer has access to the Tomcat servers on port 8080 with TCP, UDP, and ICMP. And we see that the application servers, where I was before, have access to the Redis database, Rabbit Broker, MySQL nodes, and so forth on the corresponding ports. Just to show this in action, if you will, from the public, if I visit any one of the Tomcat servers, we'll see that this will just hang around forever, but I'm able to view the HA proxy endpoint, view a sample Apache Brooklyn web app. If I resize our cluster of application servers, normally this would occur through a policy. I'm just going to invoke it manually. We'll see we get a new server provisions, and as part of that, it will join this application servers cluster. Just while that's running, I'll show you the OpenStack deployment is identical. It's exactly the same blueprint. Underneath, the security groups will be controlled with OpenStack security groups rather than AWS security groups. Also, while the AWS deployment is running, we have our third member of the cluster. It's all very well having this configuration in your blueprints, but what if you want to deploy it to a cloud that doesn't support, or in which AMP can't handle security constraints? Ideally, it would fail, won't even attempt to provision it, and we should see here very quickly that the deployment fails of everything. Security customizations are mandatory but not supported on this cloud. So you ask for security and it simply won't run without it. There is an option to ignore that, but that's more of a practice for development. All right, well, thanks for watching. That concludes this demo. Cheers, everyone.